In the typical differential rate law, you are going to see the reaction rate is expressed as a function of your reactant concentration. For example, here we have AA plus BB give you CC plus DD. If you write a differential rate law, the rate is going to equal to your rate constant K multiply your reactant, not the product, reactant concentration to certain power. Let's say it's to the power of N and the M. Where the K here is the reaction rate constant. And then this N and M is the reaction order. So the N is reaction order with respect to A. M is the reaction order with respect to B. The overall reaction order will simply equals to the sum of both. Give you a quick examples. If today I know there's a reaction, its differential rate law is R equals to K times A to the first power, B to the second power. Then the overall reaction order is going to equals to 1 plus 2 equals to 3. But the order of your A is going to equals to 1. Order for your B is going to equals to 2. So one very important thing that you also need to remember is that the rate law, this N and M, can only be determined by the experiment. Looking at the chemical equation, okay, if you look at this, you will not be able to predict the reaction orders. In other words, you will never actually write K is equals to the reactant concentration to the A's power or to the B's power. So this is never the way you got the correct differential rate law. You got the order through experiment. This is actually an experimental results for this very complicated reaction. So you want to determine the rate law for this reaction. The first step you do is you first write out the expected differential rate law. In order to do that, the first thing you do is to recognize what are your reactants. Here you should be able to see that reactant is this, this, and this. So you should be able to write your rate law is going to equals to a rate constant K multiply the reactant concentration, let's say to the X power for your BrO3 minus, Y's power for your Br minus, and then Z's power for your H3O plus. Every time you see a table like this, the first thing is write down the expected differential rate law. The next thing is based on the data you got, you put in the concentration of your BrO3 minus, Br minus, H3O plus. Everybody's actually 0.1, right? From here you can write 0.0012. That is actually your reaction rate, right? It's going to equal to your rate constant K times your BrO3 minus concentration is 0.1. You don't know the order, so you put X over there. You repeat the same thing for your other reactants. Then you're going to have one equation now. The next step you do is you repeat the same thing for all the other experiments. So for the second experiment, then I know I can write the rate is 0.0024. It's going to equal to a rate constant K times 0.2 to the X power, 0.1 to the Y's power, 0.1 to the Z's power. So I know 0.0035 is going to equal to K times 0.1 to the X, 0.3 to the Y, and then 0.1 to the Z. Very last one is actually 0.0055 equals to K times 0.2 to the X power, 0.1 to the Y's power, and then 0.15 to the Z's power. Then you want to use this equation to solve X, Y, and Z. Let's say this is equation number 1, equation number 2, equation number 3, equation number 4. If X is the things I want to solve, you keep the concentration species for your Y and Z the same. For example, here you can see that the concentration of Y is the same. The concentration for your Z is the same for equation 1 and 2. The only thing that's different is actually what? Here and here. So the things we are going to do is actually, if I do 2 equation 2 divided by equation 1. Okay, on the left-hand side, you're going to get a number of 2. So this divided by that is equals to 2. Okay, on the right-hand side, k and k cancels out. This term cancels out, that term cancels out. On the right-hand side, only thing remain is actually 0.2 divided by your 0.1 raised to the x power, which is going to equals to 2 to the x power. Using 2 to the x power equals 2, therefore you can know x going to equals to 1. All right, so that's how you solve for x. So now if you want to solve for y, you want to keep the concentration of x the same, z the same, right? So which two equations you need to use? 1 and 3, right? So in 1 and 3, you know the x, they are all both 0.1, right? Z is also 0.1. The only thing that they are different is actually your y. So what you do is actually, if I do 3 over 1, okay? So this divided by that is about equals to 3. So k and k cancels out. X term cancels out. Z term cancels out. Then all you have is actually 0.3 divided by 0.1. That's 3 to the y's power. Therefore, you know your y is equals to 1. So how do you solve your z? Which two equations to use? 2 and 4, right? So 4 divided by 2. This is this divided by that, right? So it will be 55 over 24. It's going to equals to k and k cancels out, right? X term cancels out, y term cancels out. And then you have 0.15 divided by 0.1 raised to the z's power. Okay, so if you do this, you got these equations, right? So this is equals to 1. So it's 1.5 to the z's power. Okay, so this is actually a part that most students is going to make mistake because you don't know how to actually operate your calculator to get the z. So if you do these calculations, the 55 over 24 will give you a number of around 2.3. So you can get to this point without any problem when you're using your calculator. But to solve your z, the things you need to do is actually to take log on both sides. Okay, when you use your calculator, make sure this is the things you do, okay? So you take log on both sides. Then you're going to get log 2.3 is going to equals to log 1.5 to the z's power. And this is actually equals to your z times log 1.5. Okay, so this is actually a mathematical transformation that you need to know. If in the log, if it is a exponent, okay, you can move that in front of the log. So these are things that you should know. You can actually say your z can be calculated by log 2.3 over log 1.5. Yeah, so once you do these calculations, then you can get a number of 2. For your x and y, it's easy, right? Because it's the first order, it's easy to see. But for your z, sometimes it's actually challenging. You should really know how to actually get these things operated on your calculators. Then once you have this, then you can actually say your rate is going to equal to k times your, so this will equals to 1, that's equals to 1, and that's equal to 2. What is the overall reaction order? 4, right? What is the order for your Br minus? 1. What's the order for your H3O plus? What is the value of your K? Can you know it? You can, right? Because do you know the rate? Do you know the concentration of each species? Do you know the X, Y, and Z? Can you back calculate your K? That's all you need to know for this. Got it?